We have spent um, around 13 videos building up the power of LLMs. How they work, how they train, how they generate text, how they are aligned to be helpful. Now comes the most important reality check in the entire journey. Here is the principle that matters. You must not fool yourself, and you are the easiest person to fool. AI hype often ignores this. Today we won't. This video is critical if you want to use AI responsibly, teach AI honestly, or build AI product safely. Today's core question is, if LLM um, are so powerful, why do they still make obvious mistakes? And the answer isn't bugs that will be fixed. There are fundamental limitations, design consequences, they are not effects. Three root cause drive most failures. First, no grounding. Model learns text patterns but never observe reality. Second, probabilistic generation. It asks what's likely, not what's true. Third, data limits. Training data is outdated, incomplete, and sometimes just wrong. Let's dig into each one of them. Okay. Hallucination is a confident but incorrect output. That's the technical definition. The model isn't lying to you, it's continuing the pattern that happens to be false. Watch this animation. The model types confidently. According to Dr. Smith in 2019, human need exactly 7.3 hours of sleep. Um, the confidence meter is like 95% when we saw that, right? Now it's gone. And yet the citation is completely fabricated. That paper doesn't exist. The model continued a pattern that looks like an academic citation, but it invented everything. This is autocomplete gone too far. Your phone does the same thing when it suggests looking forward to seeing you at the Mars conference. It didn't lie, it continued a pattern. LLM do this at massive scale. Two common hallucination type: fake citation. The model generate plausible sounding paper reference that don't exist, and invented facts. The Golden Gate Bridge was designed by James Sullivan in 1928. Wrong architect, wrong year, fabricated details that sound right based on pattern match. Here's what matters. Hallucination is not lying. Lying require intent deceive. The model has no intent. It generates text that sound right based on statistical pattern, regardless of whatever it is right. There's no checking mechanism, no verification step, no wait, is this true? There's no question that LLM asks itself like that. It's pattern completion all the way down. Let's understand why this happens. Root cause number one: the model has no grounding in reality. Watch this animation. On the left, a library full of books. That's the model training data. That's the model's training data. Books floating containing all the knowledge ever written down. On the right, the actual world. Sun shining, cloud, moving, things happening. And in the middle, a barrier. The library has no windows. The model can summarize every book in the library brilliantly. It can explain any concept that someone wrote about, but it can't look outside. It can't verify today's weather and confirm current events or check if business still exists. It reads descriptions of reality but never experience the reality. This creates a clear divide. On the can side, that is what LLM can do, summarize brilliantly, right? LLM summarize brilliantly, explain concepts brilliantly, write any learned style, right? Answer and answer from any pattern that it knows. But it cannot verify current facts, confirm live events, observe the physical world. The core issue is that truth is inferred indirectly from text patterns, not observed directly. It is like learning about swimming entirely from books. You might know the theory perfectly, but you never touched the water. The model read about the reality but never experienced it. Root cause number two. The model generate uh, probabilistically, right? The model generate the answers probabilistically. It always asks what text usually comes next. Never never asks itself what is true. Look at this visualization. On the left, a sphere representing probable, what is statistically likely to follow. On the right, a sphere representing truth, what's actually correct is in that sphere. And in the middle, the gap. Those particles floating through gap, those are hallucination being born. Most of the time, probable and true align, right? The sort of the capital of France is Paris. That's both statistically likely and true, but sometimes they diverge. The longest river in Amazon, the longest river is the Amazon. That sounds right. It's common phrasing, but it is wrong. The Nile is wronger, right? The gap between probable and true produces the error. When probable and true align, which is most of the time, the model seem incredibly capable. That's why we are we are impressed by it. But when they diverge, hallucination emerges and the model has no mechanism to notice. Fundamental mismatch is that language pattern can encode truth, but they can also encode plausible sounding falsehood. Model cannot distinguish sound like truth from that is truth. It optimizes for probability, not accuracy. And you have to understand that this isn't a bug, it's how the architecture works. Root cause number three is the training data itself. That is that training data itself has some fundamental problem. Four type of data problems. Outdated. The model has training cutoff, so it doesn't know about anything that happened after. Incomplete. Not everything is written down online. Noisy. The internet contains errors, lies, and misinformation. Conflicting. Different sources disagree on facts, and the model learns all versions. One of the real example is that, for example, the CEO of Twitter is Jack Dorsey. Leadership changed after the training cutoff, and the model is frozen in time. Right? Conflicting. There are 7 confident, or 6 or 5. Different education system teach different counts, and the model learned them all. Right? So there's a sort of a conflicting answer. Here's the honest truth. More data helps reduce error but cannot eliminate them. Even trillions of training tokens, the same fundamental issue remains. No live verification is there. No way to distinguish reliable or unreliable sources. No updates after training ends. The model is always looking at a snapshot of past. Beyond factual hallucination, there's another limitation. LLM can mimic reasoning pattern but struggle with genuinely novel logical challenge. On the left, a student surrounded by glowing books, representing all the linear reasoning patterns learned from the text. The student eyes are scanning, absorbing knowledge, and on the right, a laboratory with a breaker and test tube. But there is a big no access symbol. The student read every physics textbook but never ran an experiment. This is the LLM situation. It learned from text that contains reasoning, so it can reproduce a reasoning pattern, but it has no way to test those patterns against reality, no way to verify whether its logical chain actually works. The divide is clear. LLM excel at pattern-based reasoning, structured problem with familiar format, and explaining known concept. They struggle with novel logical chain that don't match the training pattern, precise multi-step mathematics, and complex causal reasoning. And here's the insight. When an LLM reason, it's generating text that looks like reasoning because it trained on reasoning text. It reproduces logic pattern but doesn't have independent verification. It's like a student who memorized textbook but never tested theories in the real world. They might sound brilliant until you ask them to actually run an experiment. Now the practical part. When should you not trust AI output? Professionals' best practice is that always verify externally in a high stake domains. Four danger zones that we already know where there should be caution is that medical advice. The model can suggest a wrong treatment or miss a critical symptoms. Legal decisions. It may cite cases that don't exist or misinterpret, some specific law. Financial advice. No real-time data access. The LLM doesn't have a real-time data access. Can invent statistics. There is safety critical information like engineering specs, drug dosage, emergency procedure. In all these domains, verify externally, always. And here's the dangerous part, the confidence trap. LLM sounds confident even when wrong. They don't say, I am guessing. They say, according to research or study shows. This confident tone makes hallucination particularly dangerous. A hesitant or wrong answer is less harmful than a confident one, but the model doesn't hesitate. The professional approach is that use AI as a starting point, not the final answer. For any high-stake decision, verify the primary source. Consult domain expert. Research that confidence doesn't reflect reliability. The model sounds equally certain whether it's right or hallucinating. Now the good news. Researchers are actively addressing these limits. Progress is real, though fundamental limits remain. Two major approaches are gaining traction. RAG, Retrieval Augmented Generation, searches a knowledge base before generating. Instead of relying solely on a training pattern, the model grounds its answer in retrieved document. This significantly reduces hallucination for factual queries. Tool usage. Let's LLM call external tool like calculator for math, search engine for current information, database for verified fact. Instead of computing internally and potentially hallucinating, the model delegates to reliable tools. This eliminates maths error and enable real-time data access. Two more approaches that are there is first is verification loops. Generate an answer, then generate a critique, then improve. Self verification catches some error. Multi-agent debate can surface inconsistencies that a single model misses. Hybrid systems combine a neural network with a symbolic reasoning, knowledge graph, or a rule-based system. Use LLM for what they are good at, language understanding, and a structured system for what they are good at, precise logic, based off both word through though complex to build. The honest assessment of these solutions helps significantly. RAG reduces hallucination, tool enable real-time data verification catches errors, right? But none fully solve the fundamental issue. The model generate probable text, not verified truth. Understanding this shapes the realistic expectations. Okay, let's verify that everything is connected. LLM hallucination occurs because model generate probabilistic language pattern without direct grounding in reality or guaranteed truth verification. They optimize for what sounds right, not what is right. Okay, let's walk through this. Probabilistic language pattern, that is, the model predict likely next token, correct? Without direct grounding, that is, it never observe reality, only text about reality, right? Only see the text about reality. Without guaranteed truth verification, there is no checking mechanism. Optimize for what sounds right, probability, but that is looking at probability but not accuracy. If that sentence feel now obvious to you, you truly understand AI limitation. You now know both the strength and the weaknesses. So how we build around weaknesses. The next video covers how LLM uses tool, memory and external knowledge, rack system, AI agent, tool calling, memory system, and real world applications. This is where AI become useful infrastructure, not just a chatbot. Next time when someone claims AI knows something, you will ask, did it observe reality or did it predict probable text? That question changes everything. Okay, see you in the next one.